Welcome to Main Street Minds with your host, Amish Munshi. This is where industry leaders and seasoned pros share their secrets to success beyond limits. Let's dive in.
Hello and welcome to Main Street Minds. Today we have a very special guest, Frank Kanu, with us. He is right here sharing all his experience on how to optimize and improve the systems that we work on. But before we get to the meat of it, the entire background is extremely interesting. So without any further delay, let me open up the floor. Frank, you want to introduce yourself and tell us the secret of like how you even got started?
All right, so my name is Frank Kanu. Like I like to tell people, I'm a very different kind of person. If you meet me, and you will immediately agree with me that it's the experience of your life. I had a job lined up after high school, and I was born and raised in Germany. And back in that time, we actually still had the draft. So I got drafted, and they went the job. And once I was done with military, I needed to find a job to start, which was hairdresser, which a lot of you folks will agree that that's really uncommon. It was actually a good entry into sales because, as you might know, it's a lot of people come to a hairdresser and have an opinion about what they really want to have done, and it's not really what should be done. Like you want to look good afterwards, right? And if you have something in mind which doesn't let you look good, that will become a problem. But over the 3 years that I did that, I figured out it wasn't really my cup of tea, and computers started getting big back then. So I went to college. I went to a corresponding university. It was actually just one back then in Germany. They were not hard to get into, but it was really hard to do the classes. A perfect example is an economics class that we had, which had a failure rate of 90%. And I was one of the few from the 10% who actually made it the first trial. And then after I was done with that class, next term, they split it up over 3 terms, which is tells you a little bit about that. They were actually very tough, because I know a lot of people have this notion that it's, corresponding university, do a little bit at home and that be that. But it was an extremely tough way of doing it. And while I went to college, I worked. So I worked in IT. I did a lot of contracting to teach IT classes, which helps you a lot. To me, the most memorable class was one where I had, after like 3-4 hours of the first day, and there was a 3-day course, I had the majority of the participants saying, "Thank you, we got what we needed," and they left. And they wrote the best reviews I ever got.
Oh, sweet. Yeah.
Yeah. So it like I told you, I'm one of a kind, very different kind of person.
Yeah. Yeah, that's a very interesting start. So, and like from there, like how did you transfer over to the corporate world?
So while I was at college, there were a few things that every student there was trying to do was moving into commercial software engineering, because back then the engineering part was the really interesting part of everything. We did very interesting work at college, programming practicum, where we tried to write a web browser, which back then they were really, so as doing that was interesting. And from there, I actually got my very first job on an ERP system based on the part that I had to do for the web browser for the programming practicum.
Yeah.
And that ERP system has really shaped a lot of what I still do and how I do. I started there in around October, and then comes the Christmas break, right? And we come back into the office on something like the 27th, 28th of December. And my supervisor hands me a floppy with a clipper on it and says, all right, by Monday, I need you to have done some of this stuff with clipper. And Monday was like 3 days. So over the weekend, I had to sit down and start learning clipper. Mind you, I was still in college back then.
Yeah.
And I had to rewrite parts of the system in clipper. The reason why we had to, this was the whole system was written in Pascal, but the reason why we had to do that was they actually were able to get their hands on a handheld computer, which was just put on your wrist like this big.
Yeah.
And the Pascal version wouldn't work on it. So we had to rewrite the whole system in Clipper so that it could work on that handheld device.
Yeah, and how did it go? Like, was it functional within 3 days? It sounds like something that couldn't
Well,
be.
my supervisor, he was actually a little bit better than me, which I usually don't admit. I won't tell anybody that somebody is better than me.
Yeah.
But he was, and he actually did roughly 80% of the system over that weekend, and
Wow.
I did the remaining 20%. And on the Monday, we had the first version that we could demo to the customer.
Oh, nice. Cool.
So we still had to do improvements and all that, but that actually leads you directly to what the biggest point in software engineering is, that always expect that something will come up that you have never done before.
Yeah.
And you have always to work really hard. You have to be curious. You have to be self-driven. If you don't do it, you will lose really fast.
Yeah, exactly. Always be open to something new, right?
Yes.
Yeah. So tell us a little bit more about from there, like what do you work on now?
So now I'm working on an ERP system for a steel mill, and I also work on a different ERP system, which is actually construction, but it's a lot more than just what people think when they hear construction. Is basically everything that goes into building commercial and non-commercial buildings.
Interesting. Yeah. And is that like a custom software or like it's in-house?
Yes, both systems are in-house systems. And with most ERP systems, the problem that you have with the ERP system is that the reason why your business got big is because you do things your way. And when you bring in a software that tries to force you into their way, that doesn't really fit your business.
Yeah.
So a lot of times they start out with a bought software package, and then they make major changes to those packages. And some of those packages, they are 20 or 30 years old. And they grow, like the one system grew from a code base of something like 50,000 lines. They are now at almost 1.5 million lines of code.
Yeah.
Now, the problem you have with a code base of that size is you can't make a tiny tweak somewhere, because you don't know anymore where the impact of that tiny change is.
Yeah. And like how easy is it to document something like that? Like is there documentation on what are the modules, what's connecting where?
Well, that depends on, some businesses are actually really good with documenting what they have, and other businesses, they just have no documentation at all. And then you run into the problem that you have to look at a lot of code. You have to do a lot of things by trial and error, because you have to figure out what impact a change has, because it's also that very often the initial architects of those systems, be it programmers or employees of the customer, they're not there anymore.
Yeah, makes sense. So like, is this system being used across multiple customers right now, or it's for just the one business?
Well, the one is at one steel mill, whereas the other system is actually used at multiple locations, and there are small differences, but the main code base has stayed the same for them all.
Okay. And what are some of the challenges that you see? Like does the business come up with new requirements that the system cannot use, or what are some of the challenges that you see right now with the systems?
So really big challenge is always the knowledge gap. So when you think about it, 20 years, 30 years of a software,
Yeah.
and there's not enough documentation. So no matter what, even if you have documentation, it's not enough. So sometimes you have, and I had this roughly half a year ago, that one of the customers asked, can't we do this? And I looked a little bit at the code and I said, but it's already in the code. You can already do it. And
Yeah.
the answer I got was, oh, we didn't know that.
Yeah.
Because whoever requested that initially wasn't there anymore.
Yeah.
So, and it wasn't really well documented either.
Yeah.
And so that happens actually quite often, that you have stuff already there and it's just not used.
Yeah, and whoever is listening this for the first time, if you're wondering like what is going on, like this is the reality of almost all softwares, right? Like this is not unique to what you're doing. Like any software that survived decades is in that state right now, but it's such important to the core of the business. It's not easy to replace. It's like replacing the whole business if we try to do something with it. It's
Yeah,
the core of the
that's
business.
very well stated. It's, you can't just take a software out that has been at a place for such a long time and replace it with something else. There are too many special knowledges inside the software that a new software wouldn't have. And like I said earlier, if the people have moved on, it's hard to find out what those special things actually are.
Yeah, yeah. Only when we make a change, we put it into production, and then something breaks in the system, saying, "Hey, oh, the supplier is not getting the orders anymore," and it's like, "Oops, that's not going to work."
Yeah, and the other challenge is that a lot of the incoming software engineers, they actually think that really big systems have like 100,000 lines of code, but the normal size of a system is like 50 is big. Now
Yeah,
we're talking about 1 million and more.
yeah, yeah, exactly.
ERP systems are monsters.
Oh yeah,
And I don't mean that in a bad way.
yeah, they do so much.
Yes.
Yeah. So, what is the technologies being used right now in the system?
Okay, it's really all over the place.
Okay.
And it's one of the battles that I actually like to fight, to convince customers of that using multiple different kind of compilers is not a good idea, because it makes it a lot harder that when you have somebody new coming in, if you have somebody coming in and they have to learn 4 or 5 different compilers to work with, that's a problem, and that will cost you a lot of time to bring them up to speed. Whereas when everything is one compiler,
Yeah.
of course, the question there is which one do you choose? But you know,
Yeah. But is it like different languages, different modules,
yeah,
like?
different languages, and multiple, like the one system has over 100 applications.
Mm-hmm.
And
Wow.
some of them are just background applications, so they run 24/7, which is another thing, that 24/7 environment is, to many people who come into software development, also not something that they would expect.
Yeah. Yeah. Exactly. So, what are some of like, are there any like new things like being implemented in the system? Like, how do you make it more efficient? And are there like any new technologies being incorporated?
That's a really hard thing to do, because we have very big databases. We have databases with sometimes more than 100 million records in a table, so that you can't just easily go ahead and say select everything from the table. You will run into all kind of problems, memory and God knows what. So you have to be very careful with what kind of data you use when. And then when it comes to the speed, so the first approach to speed is obviously the database. You have to pull just exactly what you need. And then when it comes to the compilers, you have to learn about what makes a compiler good for your task at hand.
Yeah, yeah, makes sense. And do you also have to like tune the database and like deal with everything that's in the data layer as well?
We do have DBAs usually, so they are more in charge of the tweaking, but that doesn't mean that you have to have an understanding how to tweak the data, and you also have to really look into the designing first.
Mm-hmm.
And with a small system, if you have a few hundred lines of code, you can just throw out something and you're good.
Yeah.
When the system, when you start impacting 2-3 dozens of tables
Mm-hmm.
or like 100 files of source code, you have to design what you do, or you will just create one big mess, and it will become harder and harder over time to maintain that.
Yeah, absolutely. Makes sense. So, in addition to working on this system, like, tell us more about you. Like, what was life like between going from that Clipper compiler for a handheld device till today, right? Like, what did that look like?
It's a roller coaster. I can say that for sure. There's you constantly have to keep up with new technology,
Mm-hmm.
which is it's one of my pet peeves with a lot of people I work with, that they don't read enough. I
Mm-hmm.
read at least one book a week.
Mm-hmm.
I read a lot of different blogs. So I use a feed reader. I have more than 2,000 blogs that I pull in, and then I read. You don't, when you hear read, you might be thinking that I read every single article. That's not how it works. Wouldn't
Yeah.
have the time for that. You just skim the headlines, and then when it's something interesting, you look into that. And I also start learning a new compiler like once every year or once every other year, just to stay on top of how some technology changed and all that. And you just, it's absolutely a must. But then many people don't understand that this constant education is a must in every profession.
Yeah. Yeah.
You take a doctor, for example, if they like when they came with laser scalpels and you say, no, I stick to my old technology, that's not going to fly after a few years anymore.
Yeah.
You just have to stay on top of all that and keep up with it.
Mm-hmm. Makes sense. Yeah. So, how many languages, like computer programming languages, do you have to deal with on a regular basis now?
On a regular basis, it's usually 4 or 5 that you deal with, but I have worked with over 20, which is
Yeah.
rather uncommon, but I have worked on a lot of different systems. I have worked on mainframes,
Wow.
AS400, RPG. I have worked with a whole lot of different databases, Oracle, SQL Server, Interbase,
Mm-hmm.
MySQL, PostgreSQL. You if you throw a technology at me, in like 90% of all the cases, I can tell you that yes, I have worked with it.
Yeah. Yeah. Makes
But
sense.
it's not the biggest point about it. Just like I said earlier, you have to architect stuff. The knowing a compiler very well will help you only so far. What's really important is that you put together a good algorithm. And
Mm-hmm.
when you have a good algorithm, the language doesn't matter that much anymore.
Mm-hmm. That's true. Yeah. The way, like the understanding of system design and like what's happening, what should be done, along with the accurate algorithms is the bringing it all together, right? In one.
Yes.
Yeah. So, I always like to diverge into where you came from and what you're doing right now into what does the future look like? Like, for the next 5 years, where do you see things headed in the
I will
industry?
be doing a lot more. I have done this basically since I started um, doing software development, but I will be moving into even more into coming in to help companies to solve the issues that they have with their software projects. You
Yeah.
probably know that almost every single software project is late,
Yeah.
over budget, not working. We have
Yeah.
seen those, and there are a few things that when you look at it, you can solve it. And I just go ahead and I look at all my experience. I have worked in so many different industries, and I just always look, so how would they have done this in a different industry? And then I pull a little bit you would do somewhere else and apply it. And usually that's how you move things forward.
Yeah. Yeah. Makes sense. So just before, as we are coming close to the end of this episode, like, are there any other tips that you would give somebody to like who wants to make a career in the ERP development?
Stay curious.
Mm-hmm.
Always stay curious, and don't mind the occasional night shift. And when you start out, it will be more than just the occasional one. It will be a lot of those, but stay curious and to learn a system in and out. The more you know about the system, the better you can make it better.
Yeah, yeah, makes sense. And that's very well said. So like that's an amazing journey all the way from being a hairdresser to like managing a system that just is extremely big with millions of lines of code. Like that's a great transition. So yeah, and looking forward to like good success within that sphere for you.
Yep. And it's interesting. So when you look at a lot of jobs, most professions, it's like 90% of what you do is routine.
Mm-hmm.
But in software development, when you become good, you can create stuff that nobody else has done before. Maybe not in the world, but definitely at the place where you're at. And that's when things get a little bit less routine, because now you're doing the stuff that nobody else does.
Mm-hmm.
And when you do that, you can stay way better connected to your jobs. You don't get bored. A lot of people feel the boredom when their job is just all routine. But when you do this more creative stuff, when you develop things that nobody ever thought about, that's when it gets really interesting.
Yeah, yeah, makes sense. Sounds perfect. That's a great insight into motivating somebody, saying, "Hey, let's be curious and focus on what is happening." The happiness of the results will automatically just happen. Like when you're creating something new, it automatically leads to satisfaction and happiness, and that just ends up happening the most in software.
That's how I see it too. Yes.
Yeah. Yeah. Sounds great. So yeah, this was a great episode. Thanks for sharing your valuable insights into how what you do and how you manage to like make such a big career transition.
Thank you, Amish. Appreciate it.
Yeah. Thanks, Frank.
You're welcome.
That's a wrap on today's episode of Main Street Minds. Want to share your journey with our audience? Head over to mainstreetmindspodcast.com/guest to apply.